what's going on, guys. I have some interesting questions right here. I'm going to entertain you with it. So first, let's see what's the practice question are from determinant of matrices. So the first question is asking, find the determinant of 3 minus 1 2 5 2 5. So let's do it. Find the determinants 2 3 minus 1 2 5. So here we go. 3 minus 1 2 5. So there's a formula to find the determinant. It's AD minus BC. So this is the formula. AD means this diagonal, multiply this diagonal and subtract from this diagonal. So let's see. AD is going to be 3 times 5, 15, minus, and 1 time minus 1 time 2 is going to be minus 2. So we have to write minus 2. 15 minus minus 2 is going to be 15 plus 2. Therefore, the answer is 17. Answer is 17. We found out that. And the next one is also same thing, but it's asking from 3 by 3 matrices. So 3 by 3 matrices. 2 minus 1 5 and 3 0 1 2 1 4. So this is 3 by 3 matrix. In this case, we had to use a different approach. In this case, I'm going to put this one plus, minus, plus. So if I take this number 2 out, whatever the vertical component or horizontal component of this 2 shouldn't be included. So it means these 4 are included. These 4 are included. It means 2 times 0 1 1 4. We have to put this sign second here, minus, and this one. If it's minus and minus 1 times, and this time I'm going one by one. So first I took 2. If I take minus 1, I had to eliminate whatever the vertical or horizontal component. For example, for this one I have to eliminate whatever the vertical components of this or horizontal components, like this. So the in this one it's going to be 3 1 2. This is 4. So this is 4. So this is going to be 4. And next one I am going to put plus 5 here. So whatever the horizontal or vertical in this lane is going to be eliminated. So the whatever left is, we are going to put right here. It's going to be 3 0 2 1. 3 0 2 1. Now we have to use the AC minus VD formula to find each and every determinant. So 2 times AD is going to be 0 times 4, 0, minus 1 times 1, minus 1. So minus 1, and this is going to be plus, turn into plus 1, and 3 times 4 is 12, minus 2 times 1 is 2, and plus 5. 3 times 1 is 3, minus 0 is 3. So it's going to be like this, minus 2, 12 minus 2, 10, so plus 10, and 5 times 3 is going to be 15. So 15, 25, 25 minus 2, 23. 23 our final answer. So it's answer given, so same answer. So we have done this. Let's move to the next question. If A is invertible, prove that determinant A minus 1 is equal to 1 over determinant A. So if A times Okay, determinant A. Okay, so first we have to use this one. A times A minus 1 is equal to identity. So we have to use this formula right here. So if this is true, then determinant A times A minus 1 should be an identity. A times A minus 1 should be also an identity. So in this case, we can separate determinant A and A minus 1. So I'm going to separate it and write it in different form right here. Determinant A minus 1 um, equal to I. So what we mean by I is actually 1. For example, if I x times x minus 1, what is the answer? 1. It means x over x and x cancel, answer is 1. So same thing goes to the identity. Identity means it's 1. So I can write 1 instead of identity in the next one. Determinant a minus 1 is equal to 1. So to find they're asking determinant a minus 1 is equal to 1 over determinant. So I'm going to keep the determinant a to the power of minus 1 in the left side and switch the determinant a to the right side. So when it goes to the right side, it goes down here. It's like basic math. So this is our final answer, and we proved it to be true. That's how it works. And we are done with this question. Next question. Let's do the next question. And let A and B uh, two 4 by 4 matrices. If determinant A is equal to 2, determinant A is equal to 2 and determinant B is equal to 3. B is equal to 3. Then they are asking find 5a minus 1, 5 a to the power of minus 1 and b to the power of t, b to the power of t. So let's see what we can do right here. So b to the power of t is equal to b according to the uh, determinant rule. B to the power of whatever to the power of t is equal to whatever, like a to the power of t is a, b to the power of t is b. And also if a inverse, it means it it mean the a is 1 over determinant a. Like if it's for example this one. So let's see, well, let's do the number here. So bt, we know it's we know b is 3, therefore bt also 3. And if it's a inverse, it's 1 over 2, so it means 2, 3 over 2. And in this case we have to, like, if it's 4 by 4 matrices, we have to power whatever the matrix. If it's 3 by 3, we have to power it by 3, whatever the coefficient we get. If it's 4 by 4, power 4, 5 by 5, power 5. That's a determinant rule. So I'm going to apply this one here, and that is our final answer. Let's go to the next question. Next question is asking, let's be a 3 by 3 matrix, and if determinant coefficient is equal to 4, find determinant A. This is a tricky question. I don't understand this. So in this case, I'm going to skip this question, and let's move to the next one. Let A is equal to A, B, C, D, E, F, G, H, I, and determinant A is equal to, find determinant of this one. So in this case, this 2, if it's something like this, so 2D 2e, that column, uh, the 2 is common factor. 2 is common, so we can take it out. It doesn't have to be 2 in every row. If there is one row is with common factor, we can take it out. If all of 3 are with 2, we have to take all the 2 out, like 2 times 2 times 2. So in this case, it's just one row is 2, so I'm going to take this row 2 out, and here it's minus 1 is common, so I'm going to take this minus 1 out. 2 times minus 1, and they have given determinant a is 2, so I have to multiply this by determinant a, so it's going to give me minus 4. Minus 4 is the final answer. And the next one is saying a, b, c, determinant d, e, f, g, h, I. Find the determinant of this one. So since this one is like this, 2a plus d, 2b plus c, c plus f, is there anything common? Actually nothing common, because if you take, you can't take 2 common, because if it's 2 common, it should be 2a plus 2d, but it's in this case it's 2a plus d, it means it's not common. So 2b plus e, 2c, nothing is common, we can't take anything out. But the only thing we can see is this one is swapped. The GHI is swapped to the first row, and the ABC is swapped to the third row, which means we have to put the minus sign for whatever the determinant we get. So in this case, they have given the negative 3. So if it's swapped, every time we swap, the 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 the, the, the value changes, like positive. Like if I swap it's one more time, it will become positive. If I swap another time, it will become negative. So it will keep changing as much as you switch. So in this case, it's swapped only one time, so it's going to be negative 3. And the final one is asking, use Gauss method to change the into triangular matrix, then compute its determinant. So triangular, I saw you first example of triangular matrix, 1 1 0, 1 1 1, 0 1 1, and 0 0 1. So in a in a triangular matrix, whatever the number below the diagonal should be 0. That's an example of triangular matrix. So we have to use Gauss method to change this one into triangular matrix. I'm going to show you how to do that. So 2 minus 1 5, 3 0 1 2 1 4. Let's start it from the bottom. So to make the bottom one 0, I have to multiply the first equation by negative and add it to the third one. So minus r1 plus r3 is going to be 0, plus 1 is going to be 2, and minus 5 plus 4 is going to be minus 1. And the second one, I'm going to change the second one first column into 0. So to change that one into 0, I had to do what? Multiply the first equation by 3. No, multiply the first equation by 3 minus 3 by 2 and add it to the second one. So it's going to be minus 3 by 2 r1 plus r2 plus r2. First is going to be same, we are changing the second one. So in order to do that, first we keep the first one same, and the second one is going to be 0, 0, and minus 3 by 2 plus minus 1, sorry, minus 3 by 2, multiply by r1 minus plus 3 by 2, plus 3 by 2 plus 0 is going to be 3 by 2, and then the third row is going to be minus 3 by 2 times 5 is going to be minus 15 by 2. Minus 15 by 2 plus 1 is going to be minus 13 by 2. Then the third one, it's 0 to minus 1. Now we have successfully changed the first column. Now we are moving to the second column. In this second column we have to change the third row into 0. To do that, I have to multiply the first column, second column by 4 and divide it by 3 and negative it and add it to the third equation. So 2 minus 1 5 and 0 3 by 2 minus 13 over 2 and minus 4 by 3 plus R3. This is R2 and this is plus R3, which is gonna give me what? 0 0 and minus 4 times 13 is gonna be 56 plus 56 plus 56 over 6 plus 56 over 6 minus 1 is gonna be plus 65 6 over minus plus minus 1 is gonna be um, say 6 over 6, so it's gonna be minus, wait a minute, minus 4 over 3, so minus 4 over 3 multiplied by R2, right? Okay, and added to the second one is 0, okay, and second 26, okay, minus 52, actually minus 13 times 4 is equal to minus 52 over 3, so minus 52 over 3, actually minus minus cancel and plus 52 over 3, 50 plus 52 over 3 times 2 plus 52 over 6 plus 52 over 6 minus 1 plus 52 over 6 minus 1 mean plus 52 over 6 minus 6 over 6. It's going to be plus 52 over 6 minus 1 minus 6 over 6 is going to be plus 46 over 6 plus 46 over 6 plus 46 over 6. So we can simplify this one by dividing it by 2, so it's going to be 23 over 3, 23 over 3. And according to the determinant law, if we have a matrix triangular matrix, we can just simply multiply the diagonal to get the determinant. So let's multiply the diagonal. 2 3 by 2, 2 multiplied by 3 by 2 and 23 by 3. So 3 3 cancels, 2 2 cancels, and we get the 23. That's our final answer. Let's check the answer. 23. Oh wow, we did it right. So I hope you guys enjoy this video. I have more stuff to come up with. uh, just um, keep on watching. Thank you guys, thank you for watching.